Hello everyone. Today we'll be discussing a binary tree question. This is a medium level lead code question, and as you can see from the title, this is reverse odd levels of binary tree. So we will directly jump to the question with an example. So in this particular question, we have a perfect binary tree, as you can see in this example drawn, and as the question asked, we want to replace the nodes of odd levels of the tree. So odd level, as you can see, because I'm indexing it with 0, first we are targeting level 1, which is 3 and 5 of the root node 2. Then we are targeting level 3, which is actually the level 4 of this, but because of the index, I'm talking about level 3. So now what we can see is like what this question is being asking us to do is this particular root node 2, we want to replace the left of 2, that is 3, with right of 2, with that is 5. So it will result with this, like it will have 5, which is the right, which was the right of 2 as the left node, and 3 will be similarly it will be the right node. But the most tricky thing is the level 4, because it's having multiple left and right nodes. What we're expecting is the 7, which is the leftmost of node in this particular binary tree. We want it to be replaced with the rightmost node, that is 36. Similarly, 9 with 32, 10 with 22, and 14 with 15. So we will explain why, how to do this, but we'll like jump to the solution right now. Okay, this is a C sharp code. What I have done in the start is we are checking for a root being null, because we want to check if the root is null, it means we don't have to return anything and we'll be returning null. I'll paste it here just for good reference. Okay, so as you can see, we have started with a null check. If the root is null, we are definitely returning null. But we also know, because we the first odd level will be 1. So why we are bothering about the root node, we'll start this function with the level 1. We created a void function with left node, right node. As you can see, the name is having node left, node right, and we are sending a level as well. We are sending level because that's what we are keeping like keeping in mind. Okay, so seeing the question, the solve method we have made, which is like first we'll having a null check again. If the left node is null or the right node is null, which means we have reached the last or the end of the binary tree, we'll just return it, because we are calling it as a recursive function. And then we have a function called to check if the level is odd level. We have just mod it. If the mod of 2 of the level is not equal to 0, it means it's a odd level, and we are just swapping the values. As you can see, we have created a function. It's having a temporary variable, and we just swap the value. Now you can see we have called this function twice, alternating. First we are calling it with the left, with the right function, then we are having right with the left, and then we are also incrementing the level with 1 just to go to the next level. Now just for the visualization, we can understand why we are choosing these alternating nodes and why we are calling the function twice. Because in this particular tree, we want left node of 8, that is 7, to be replaced with a rightmost node of 34, that is 36. Similarly, we want the right node of 8, that is 9, to be replaced by left node of 34, that is 32. That's why we are calling this function twice, as you can see in the solution. So thank you.